Thank you for joining Modern Civil and IDAS webinar on becoming a pipe modeling wizard. My name is Salome Fourie, and I'm the Infrastructure Accounts Manager. Presenting today as Anro Human. Anro is one of our applications engineers and is part of our Modern Infrastructure team. We would also like to mention for the month of November, we will be having a 15% discount on the DevaTech IDAS software, new software. For more information, you're welcome to contact me. For any other questions on the webinar, please add it to the Q&A box below, and Anro will also answer all the questions at the end of the presentations. This presentation will be recorded and available after the webinar, so you're welcome to see it on our YouTube channel. And if you need any other information, you are welcome to contact me, and all the details will be in the chat box. Anro, over to you.
Thank you, Salome, and good morning, everyone. Okay, so once again, welcome to the Civil 3D and IDAS webinar. So that's going to be your guide to becoming a pipe modeling wizard. All right, so let me just quickly open my Civil 3D here, and then we can get started. All right, so the main things that I'm going to be covering in this webinar are going to be basically the differences between Civil 3D and then using IDAS in conjunction with Civil 3D when modeling pipes. So the first drawing that I've got open here is my bulk water drawing. This is just a bulk water pipeline going from a reservoir to a tank. Now, as it says here in the description, it's going to be modeling with Civil 3D. So what I have here is I have a surface, and then I have some locations indicated by the circles. Those are going to be my main structure locations. I've also just created an alignment here that's going to indicate where our pipe is going to be sitting. So the direction is going to start from the bottom here up to the top. So to start modeling a pipe network just with vanilla Civil 3D, I'm going to open up the pipe network creation tools. All right, so let's call this bulk water. Parts list that I'm going to be using, I have a custom parts list, which was given or created by DevaTech South Africa, and it contains multiple different parts lists containing all of our South African standard parts, pipes, and structures. All right, my surface is going to be final surface. Alignment is the bulk water alignment which I've created, and I'm not going to put any structure labels or pipe labels on this yet. So I'm just basically going to draw out this entire network. Now, first off, it uses my parts list, which is water. All right, now I have access to this entire parts list here. Now let us start. The structures that I'm going to be using are just going to be junctions. My pipes that I'm going to be using, let's call this SteerFlow class 12. Let's make it a 250 meters, just as an example. I'm going to be drawing pipes and structures. All right, so I'm going to start off by drawing from the end here, and then just snapping to my alignment vertices. And that is how you would manually draw out a pipe network. Now, when we get to Stormwater, I'm going to show you guys how to use IDAS to create an entire network automatically from a set of polylines. All right. So, just minimize this checkbox. So then, what you would usually do is you would create a profile view. So I can basically go and close this now. We'll show some more functionality on that a little bit later. Now, what if you want to, for example, change some of these structures? Now, to do it normally with Civil 3D, you can simply select for example, one of these junctions, right click, go to swap part. And you can then select, for example, let's say a reservoir. Go. Reservoir. So that switches to a reservoir. Let me just quickly control my masking there. Just switch off these so that we can clearly see what these structures look like. All right, so I'm going to do the start and I'm going to do the end. So part to a tank. Now this process is fairly similar to the IDAS version. Just going to rotate this a little bit here. And there we have our basic pipe network drawn out. Now we do not yet have any other parts drawn in here. Now let me just quickly open up this drawing. Right. Now, what I have over here is this one. What I have over here is that I just have some labels indicating the different pipe names as well as the structure names. Now, when you create structures, they are manually called, or they are automatically called manholes. So that is what that structure is automatically called. Now, I've also got a profile view or a longitudinal section here with the pipe network as was drawn out. Now, when you draw this out with normal Civil 3D, or just plain in general, we don't really have any vertical design taking place here. Now, Civil 3D on its own does not really provide as much control as you would like over the inverts of your structures and pipes, right? So what you would usually do is, if you want to control the inverts of a pipe, I can select, for example, this pipe, you can control the start invert elevation and the end invert elevation from the properties manager, right? But you can also go and edit these in plan view. You can adjust the grips. You can, for example, take the top, or let's take the invert for this example. And as you can see, you can input a elevation value here. So let's say, for example, 1355, and that would update the inverts. Now, with IDAS, we get a little bit more control over this, right? So let me head on over to IDAS. I can go and say, adjust inverts. Now, what do I want to do? I want to adjust the entire network, that is bulk water. For final surface is going to be my reference surface. That's what's going to be determining my cover. Okay, I want to adjust my pipe elevations as well as my, let's leave the structure room elevations for now. So let's just adjust the pipe elevations first. So let's say we want a cover of 1.5 meters. That is to cover, and that is below the surface. I'm not adjusting the structures as of yet. So then I'm going to hit OK. Now, it is important to note that when working with cover, cover is only taken at the start and end of a pipe. It does not measure this along the pipe. Now, also, when you want to add some additional parts here, let's say, for example, we want to go and add a low point over here. That is where we're going to be putting our pipe, our pump. And then we're going to be adding some additional vertices along this network. Now, Civil 3D does not really provide any control over this. So what I just went and did is, for Devotech, they added a function for insert structure. So I can select insert structure. The network is bulk water. Structure group. Let's say, for example, I want to add just normal junctions for now. I'll switch the parts later on. junction. And the depth below NGL in cover for our pipes are going to be 1.5 meters. Now you can interpolate it from the structure depth from the current pipe slope, but I do not want that because our pipes are sitting above ground. So I'm going to hit OK. Now I can select a profile view. So I'll just select the grid. I'll select a pipe to divide. Okay, so let's firstly say, let's take this one. I want to add a point down there. Let's split this one up here. As you go along, you select the pipe and you just click along the chainage and it will automatically add in these pipes at those intervals. Let's add one over here. Let's maybe just for example, add one over there, add one here. So I'm just quickly going to navigate through this drawing and add some pipes, structures. Next pipe here. Okay, so basically what happened now is as soon as I did that, it drew in my structures, but I've still got some of my structures sitting down here. Now, what if I want to update those structures so that they basically snap to my pipes and then so doing adjust my profile view? I can just go back to adjust inverts again. This time I'm going to switch off the adjust pipe elevations and I'm going to switch on the adjust structure rim elevations. Now I'm going to select 0. Now, although these are just junctions, so they're going to be sitting on the pipe itself, it's not going to be like a manhole which has a rim that goes to the surface elevation. When I select 0, it's going to take it up as high as possible, but not beyond the pipe elevation. And then just click OK. There we go. Now our structures are all sitting like so. All right. Let's go by here again, insert structure again. Just want to do that last bit. Junction. So pipe. There. And there. All right, so we just run that again. Just structure and elevations. Okay. There we go. So that is how you would basically automatically vertically design this, this network. Although adding in these points, you specifically just select the profile view, select the pipe, and add where you want that node. It will automatically add it in at a certain cover level. All right. So that is basically it for the vertical design, how you would go through these vertical designs. Now you can go and swap these parts. You can go and indicate where you want vertical bends, horizontal bends, vertical and horizontal bends. But just to save time, I've already gone and done that. So you would basically just switch the parts and then rename your structures and your pipes. All right. So let me open up the next part. So what we're going to be moving over to now is going to be the analysis of a bulk water network. So just showing you how you can use IDAS to analyze a network within Civil 3D. Civil 3D on its own does not provide any pipe network analysis functionality. You would need to use storm and sewer analysis for this. Just open up this drawing. Now, just some additional information on IDAS. It is built on the EPASWIM and EPANET engines. So it uses that to do our analysis. All right, now as you can see, I've gone ahead and I've renamed all of my structures. I've also swapped these points to reservoirs. wherever I have a change in the horizontal direction, I have added horizontal and vertical bends because these do change, they do change in slope between the pipes at these nodes. HV, as you can see, you do have a slope difference. There's a 2.85 and there is a 3.09%. Right, so this is what our vertical bends look like. Those are at the nodes or at the vertices on our alignment. Then I've just gone and I've added a pump at the overall low point of our network, which is over here. And wherever we have a low point, I've added a scour valve, and wherever we have a high point, I've added a air valve. All right, and then just the rest of the remaining nodes are all vertical bends. So this is a fairly simple network. I've just gone through and renamed all of those as well. Now, just to show you guys, if I go to analyze, you can only work with these pipes in storm and sanitary analysis if you do not have IDAS. Now, I don't really prefer doing that because it is fairly manual. Now, when we go over to IDAS, I can open up my pipe manager. Just takes a little while to load up. It is a separate interface from Civil 3D, but there is constant direct communication between the two. It's busy loading in my surfaces and pipe network. All right, as you can see, I've got my contours over here. I have my pipe network. So let me just switch off my contours and labels. This blue rectangle is the longitudinal section of my pipe network. As you can see, you have a little legend over here on the side, and that indicates to you what type of structures you're looking at in your plan view. I have my reservoir to my pump, all the way through to my tank. Now, let's quickly analyze this. Now, for this example specifically, for my pump, which is the important part, I have already created a pump curve. All right, so this is the design pump curve, which is suitable to this network. It's already been tested, it's already been analyzed. I know that this pump works. But just to show you guys how you can add multiple pump curves, that's on the library tab here. I'm going to go add a new curve. So let's call this design. Okay, it doesn't like the spaces. So I'm just going to have to go and add an underscores. All right, this is a pump curve. Might actually be too long. So let me just remove this. There we go. Okay, so this is a design pump. It's my design pump curve. I'm going to add 3 values to this. As you can see, it adds an empty table here, basically. Now let's see, it was 40, 80, and 100. So I'm just going to basically replicate this. 40, 80, 100. That is the flow in liters per second. It increases as it decreases, right? And that was 110, 90, and 60. 110, 90, 60. And that is how you can add a pump curve. Now let us quickly navigate over to my structures. I want to quickly go and check how my reservoir controls the flow into the rest of my system. So I'm going to make this depth below surface. That's going to be 0. The tank is going to, or the reservoir is going to be level with the surface. We do have a high point over here. The water depth, the head at that point would be, let's say, 6 meters. And that's going to provide you total head over there. Now let's quickly go to our pumps. Let's firstly see the outgoing pipe from our pump. If I look at it like this, I've got P1, P2, P3, and then P4 is the outgoing pipe. So let's change that, P4. The pump curve, as I can see, it's currently got none in here, but let's select that design pump curve. And then the speed multiplier, this always has to be 1, because if it's at 0, you're not going to have any speed provided by your pump. All right, so then let's go look at the valves. You can have a look at your air valves here, provide some minor losses if you want to. You can see the bends that have been allocated to it. I'm not going to add any minor losses in for this example. Scour valves are the same. All right, and I think we just need to go and look at the tank. What is our tank? It's above surface. Let's mark that also a surface level tank. The initial water depth, I'm going to make 2 meters. So it starts at 2 meters full. Minimum water depth is 0.1 meters, and then the maximum water depth is 12 meters. So that's how full this tank can be pumped. Now, just for analysis reasons, I've made this tank diameter 100 meters so that we can run the analysis for prolonged periods, and the chances that it will fill up a 100-meter diameter tank should be fairly slim. All right, so I just provide a little bit more capacity to the tank for analysis reasons. Then under conduits, I'm just going to go and select all of them, because I just need to add a roughness coefficient. So let's go say roughness coefficient. Because this is UPVC, let's go 0.615 for our roughness coefficient. Okay, so velocity all has exclamation marks because the analysis has not been run yet, and these exclamation marks at length just indicate some of your pipe sections that are too long. In other words, you would usually go and add an additional structure there just to reduce the length of these. All right. Now we can go to analysis. Firstly, hydraulic parameters. We're using liters per second, the Darcy-Weisbach equation. We have some additional settings that you can see here. Let's run this analysis for, let's go, so the time step is 1 hour. Let's see when we run it for 21 hours. So that's from the 3rd to the 4th, from midnight up to midnight of on the morning of the 4th. All right. Okay, so you can right click anywhere, but I'm going to go to analysis and click analyze. It says warning, see report. Right, click here to go to my report. And it says that my tank is filling at 2 meters, it's balanced, and then you get some pressures here. Now, you can see the demand. In other words, the reservoir is pulling water out at 73 liters per second, and then the tank is filling at 73 liters per second. Now, do note that this is just for an example. So sometimes some of these values in these examples will not look very realistic. All right. Head loss shows us our link results, and it shows us all of these results per hour. All right. So it starts at 0 hours, and then 1 hour, node and link results, 2 hours, all the way up until the end. All right, you can see your flow in your pipes and so forth. Now do note this is very high. All right, so let's go and look at our conduits. So we've got our flows now inside of these pipes here, and we can then simply go and update these results to Civil 3D. You can then see the results here. It updates these to our bands, our design flow, and design velocity. And that's not too bad, actually. All right, now let's say, for example, we want to see the entirety of that. I'm just going to change the height to just a bit higher than it should be. And then you can see your hydrology grade line and your energy grade line directly imported into your Civil 3D drawing. All right, and that's the basics of analysis for bulk water. So the next part that I'm going to be showing you guys is just water reticulation. So I've already got a drawn out water reticulation network. So it's basically a continuation of that previous drawing, where we are now feeding from the tank towards the residential area. Let's just give it a second to open up. Go. All right, so basically what I've done here is I've now drawn from where we placed our tank in the previous example. I've gone and created a network. Okay, so I did use the automatic, the IDAS water reticulation wizard to do that with polylines, but I'll show it to you guys in the stormwater example. Got a nice example set up there. All right, so I've basically got everything drawn out here. Now, what if we want to add parts with normal Civil 3D? Just in plan view, we've already covered the IDAS way of doing it, but the IDAS way of inserting structures only works on profile views. Now, what if we only have a plan view like with this bulk water here? Well, in that case, it would actually be better to use the normal Civil 3D edit pipe network functionality. So I want to add some gate valves and I want to add some fire hydrants. So I'm going to select one of these pipes and I'm going to open up this edit pipe network. That's going to open up the pipe network creation tools, network layout tools. Now, here it says we are using the parts list for water. The reference surface is funnel surface. And we don't have any alignments in here. We also don't have any profile views. Now, what structure do I want to add? Let's go with some gate valves. Gate valves. I'm going to select gate valve. I'm not going to worry about the pipes now because these pipes have already been drawn out. Then I'm going to specify structures only. And I can then go and add, you will see with that weird orange color, marker there, it indicates that we are going to add a part to this network. If it doesn't indicate it, then it means you're missing the network. I'm going to go add a gate valve in there. Let's go add a gate valve in here. So yeah, let's add one in there, this example. Right, that adds in our gate valves. Now you can go through and you can rotate these however you see fit, and it will make it look quite nice. All right, now I want to add some fire hydrants. So I'm just going to add in a standard fire hydrant. I'm going to select structures only once again. Now do note, this interpolates basically the pipe slope, so it doesn't adjust the pipe slopes or anything. It just adds the structure in. It splits up the pipes and it adds the structure in on that slope. All right. So, okay, I'm going to have a house connection going in there. So let's put this little offset. Let's say the driveway is going to be somewhere here. I'm going to add a fire hydrant there. Fire hydrant over here. And one over here. All right. That is how you add parts manually to a pipe network. You will see that it does split this. So it keeps the original pipe, like for example, pipe 4 here, and then it adds another one, pipe 4, and then in brackets 1. So you would just have to go through and rename all of these parts. I'll just quickly show you guys what those fire hydrants look like. So I go and switch off that masking. We go fire hydrant, and then our gate valves. These are just normal junctions. All right, so that is how you can add parts manually in Plan View. The next part that I'm going to be covering is going to be house connections with IDAS. If you want to do house connections with normal Civil 3D, you would have to have the relevant parts list, and then you would just have to add those in the same way in which we drew our bulk water network, basically. We select a part or a structure, you select a pipe, and then you draw those in at the relevant positions. Take a little while to open. All right, so what I've gone and done here is I've already gone and changed this now to a reservoir. This was a tank with full bulk water, but as soon as we switch over to water articulation, this needs to become a reservoir. A reservoir basically says that this point is now being fed constantly by a bulk water network. So this can be assumed that it has an infinite source it's basically an infinite water source for the water articulation. All right, I've also gone and added in all of my gate valves. I've gone and added in all of my fire hydrants and my end caps. I just swapped these structures to end caps and I've just rotated all of them. No vertical design has taken place yet. I will do that once after we've added in our house connections. Now, let's say we want to use IDAS. We want to go to the water drop down and then to our house connection command there. So this is going to be for the network water articulation. That is the pipe. So I'm going to go 40 millimeters for the dual house connections and then for the double house connections, and then 25 millimeter class BN10 for the single house connections. So let's go 40 millimeters there, single house connections. Let's firstly do our double house connection. There we go, double house connection. The connector to create is going to be a saddle, and then the reference surface is the final surface. I'm simply going to hit OK. Now, these blue circles that I have here, if they are on a cadastral property line, it's going to be basically a double house connection. If they are inside, it's going to be a single house connection. So let's go and add one in here. As you will see, it does snap directly to that one. I will show you more control over this. Snap to the center there. It goes over and connects perpendicularly to that main pipe. Let's go over there. Let's add one there. Add one here. Now, I don't have any circles indicated over here, but I will just add one for these two, and then a single house connection over there. So snap to the nearest for this one. And then you will see that it does go to the closest pipe. So I can promise you now, if I add one here, it's going to snap to my end cap there. And I don't want that, right? So what if I want to target a specific pipe? Well, then I can just go in this command, I can go and select pipe. I will select the target pipe there, and then snap here. Right, I will show you how to adjust the rotation of these parts. Now I can go back to automatic. Let's go auto. I'm not following a specific order necessarily here. I don't want it to go under the road again, so go there. Yeah. And there. See how quick it is to add these house connections. It's all in one command. So double house connection, single, single. All right. This. Add some of those in there. And now I believe I can go and add my single house connections. So I'm just going to go and run that house connection command again. I'm going to change my pipe to 25 millimeter and change this to a single house connection. So these are covered. I'm just going to put it here somewhere. That house. This house. This house. So I'm just doing it very roughly. And then I can simply hit escape. Those are now my house connections. Now, if you do want to rotate these, you can simply select the house connection and then rotate it as you see fit. These little single house connections rotate in line with the pipe, and then it will look nice. Right, but I'm not going to do all of these. Basically, what I'm going to do now is I'm going to show you how you would vertically design this network. So I'm just going to go to a 3D view quickly. So you will see that these pipes, basically what's happening is there's a certain distance underground, right? But what if I want to go and adjust the cover of these pipes? Let's say we want to make it 0.8. As you can see, we do have some funny slopes happening here. So we want to have the entire network, seeing that it is being pressure fed here, the slopes don't really matter that much, as long as we have a constant cover. So what I'm going to do is I'm going to adjust the inverts by use of IDAS. Entire network. Let's go just pipe elevations, and then I would like to adjust the structure room elevations as well. Now I will show you what I mean. Let's do this afterwards. So the amount here is going to be 0.8 meters to cover below the surface. I'm not going to adjust the structures yet. I'm just going to hit OK. Right, that adjusts all of my pipe covers, as you can see here. Now, the only problem that we have is our fittings or our junctions, as well as our saddles, are all still going towards ground level. Okay, so basically what I want to do is I want to go and change it. I'll come back to this view in a second. I want to go and make it so that all of those parts are in line with our pipes. So those would be our house connections can be at ground level. Our fire hydrants can be at ground level because those need to basically stretch up there, but all of our gate valves, as well as all of our junctions and our saddles and our end caps need to basically be, they can't stretch to the ground because that's just not how those structures work. So I'm selecting one of each, and I'm going to right click and select similar. Hit escape. Go to IDAS, adjust inverts. I can say select parts. There, type P for previous, hit enter. It selects all 53 of those objects. And then hit enter again. I'm not going to adjust the pipes, but I'm going to adjust the structure and elevations. Now, these need to go to sit in line. They need to be adjusted to sit in line with the pipes, right? The rest of them are all stretched towards ground. Now, my pipes are at 0.8 below ground, so I can change this to any value more than that. So let's say 2 meters below surface. The reason why I select a value more is because these objects will be stretched down, but they cannot be stretched further down than the pipes. So they will basically be snapped to our pipes. So that's going to be 2 meters below surface. You can even choose 5 or 10 or whatever. It won't go as deep. And then adjust structure sump depth. Have sumps there. And just hit OK. Just process. And there we go. Let me go to my 3D view again. There you have it. All of our saddles, all of our gate valves, as well as our junctions are now in line with our pipes. It does not go below that cover level. All right, whereas our house connections and all of those, they do seem fine. There's our end cap. It also sits in line with the pipe. Whereas these, they all go to ground level for our connections and our hydrants. All right, so that is how you would add house connections and vertically design a bulk water network. Now let's go over to the analysis of this quickly. I apologize that it's taking a little while. All right, so this is basically just a few steps further than what I've gone with in the previous example. I've rotated all of these structures. I've gone in, I believe I renamed all of them. Let me just check. Yes, no, I did not yet. Okay, but that's not a problem. Okay, so what I'm going to do now is I'm going to do the analysis. Now, just a little bit of an extra part on this first part here from our reservoir up until the rest of the network. I've just gone and created a profile view just to see, if we need to adjust for cover here. Now, I can see some parts where I can adjust for cover, but you would do that exactly the same as what I've shown in the bulk water example, where I insert a structure, choose a cover, and add a junction over here. That would just add a vertical bend fitting for us, just so that we can achieve cover, right? So it's always good to just check some parts of your network to make sure that you have adequate cover. Once again, the reason for that is because cover is only measured at the start and the end. Okay, so to do some analysis over here, what we would need to do is we would need to open up the pipe manager on IDAS. As you can see, I didn't rename any of these parts yet. I'm not going to worry too much about that right now. I have my 3 fire hydrants. I have all of my gate valves, my house connections, and so forth. All right, so let me just quickly see something here. I want to check whether the rest of my network is connected to my reservoir. So I'm going to select my reservoir, right click, and say find connected parts. All right, so I do believe I did go through this and connect all of the parts that were not connected. I just basically adjusted the pipe so that it snaps back into the structures, checked all the flow directions and so forth, and everything is good. Okay, so what do we want to do now? Well, first of all, let's see. Okay, cool. So structures. let's go look at our water source first. Now, it doesn't currently have a name, but you can rename these parts in here. So I'm going to rename the reservoir here to reservoir. Depth below surface, I'm just going to change this so that it's on ground elevation. And then the water depth, I believe I changed to 12 meters just to provide, I believe I did it the same as what we specified in our tank, because that's the only thing that really matters here is the head at this point provided towards the rest of the network. We don't have any tanks, we don't have pumps because this is it's basically fed by gravity. This is at a high point, so that provides the pressure into our system. Valves, you can go and have a look at your gate valves, add minor losses. The maximum pressures here are not yet specified because we have not yet run our analysis. Let's go look at our fire hydrants. Okay, so they have a depth below surface, they have a demand. So let's specify a demand of 25 meters per second at each of these. Okay, what we want to do then, we want to go and have a look at our single house connections. I believe our single house connections had a demand of, let's see, values, demand. I believe these were 0.065 liters per second for the demand at these, and then the double house connections were 0.13 liters per second demand at these. Okay, now for this analysis, you will see that we can add demand patterns. Okay, I'm not going to do this right now because when we run our peak flow analysis, IDAS will create these patterns for us, and then I will just quickly explain what those do. All right. So I believe I just need to add the roughness coefficient to my pipes. It's HDPE, just indicates that one of these pipes are too long. It's at 284 meters. That is this initial one. So you can go and add some nodes along there. Provide some vertical bends just to reduce the length of the pipes there. All right. Hydraulic parameters, let's stick to this. And what I'm going to do is I'm basically going to run this analysis for 4 hours, okay? Now, what's going to happen is at 0 hours, none of our house connections or our fire hydrants are going to be drawing their demand. So basically, none of the house connections or fire hydrants are going to be open. At hour 1, only our house connections are going to be open. At hour 2, our house connections and fire hydrant 1 is going to be open. At hour 2, our house connections and fire hydrant 2 is going to be open. And, oh, sorry, that's time step. Yeah, and then at hour 4, but let me basically show it to you when we run this analysis. I think it's better if I show it to you and explain it to you. Okay, so let's change this end analysis time to 4 hours. It's going to be on the 3rd up until the 3rd. So it's going to run from midnight up until 4 in the morning. All right. So let's then go to analysis and run our peak flow analysis. It says morning C report. I can go look at my report. So this says at hour 0, none of our nodes are pulling any demand. Okay, so we've got 0 flow in the pipes. It's basically static. Then at hour 1, you can see that we have our house connections. That is the 0.7 for single house connections and 0.13 for double house connections. And you will see what happens at the reservoir as well, how much water it is drawing. Negative 0.02 means that 2.02 liters per second are being pulled from that reservoir to feed these house connections. You can see then that we have some flows in the pipes. Okay, as long as you don't have negative pressures, it should all be fine. Then at hour 2, fire hydrant 1, as well as our house connections are open. We have some more flow in the pipes, right? As long as I don't have negative pressures. At hour 3, our house connections and fire hydrant 2 is open. Unfortunately, I haven't renamed these yet, so they don't reflect that, but you can trust me. This is fire hydrant 2. And then you will see some flows in the pipes here with the pressures. And then at hour 4, all of our house connections as well as fire hydrant 3 is open. So it basically tests all of our pipes during these time steps. With all of, unfortunately, in this one, we don't test it with all of our fire hydrants open at the same time. All right, so I'm going to go to my library and quickly explain this. Here you see we have the first one. Where is this one? So this is for the house connections. So at hour 1, okay, hour 1 or time step 1, which is at hour 0, the multiplier is at 0. So there's no flow into our house connection. But at time step 2, 3, 4, and 5, that is hour 0, hour 1, hour 2, hour 3, and hour 4. At those 4 time steps, these are open. I'll go and have a look at my fire hydrant. This one. Okay, so at hour 2, only our house connections are open. At hour 3, sorry, at hour 1, only our house connections are open. At hour 2, our fire hydrant is open along with our house connections. Then at hour 3, our fire hydrant 2 is open along with our house connections. And at hour 4, fire hydrant 3 is open with our house connections. So these patterns basically work in tandem with each other. Fire hydrant 1, fire hydrant 2, fire hydrant 3. All right. So that is how the peak flow analysis works. You can then go and have a look at your conduits to see your flows in your pipes. Now, do note these exclamation marks. This is because on my analysis, I have a minimum velocity set. Now, this does not, it does not control your velocity in your pipes. It only indicates, so you basically say, what is the minimum flow and the maximum, or the minimum velocity and maximum velocity that you want in your pipes. And it will notify you when you are under or over those values. That is what those exclamation marks are for. All right. I did not change these. Therefore, it is just showing me those standard exclamation marks there. All right. So that is it for our water articulation. Now what I'm going to show you guys is how you can automatically model an entire pipe network by use of IDAS. We are going to go a little bit over an hour, I believe. This is quite a stacked webinar. So let's go open up Stormwater. All right. So what you will see here is that I have drawn out some polylines. They just got a thickness to them, but I've basically gone and identified where I have my low points, where I want my inlets and so forth. I'm not going to go too in depth over this. This is mainly just to cover the modeling side of things. All right. So what I'm going to do, well, just to show you first, I've created a layer for this ACAD pipe network. So it's basically just on its own layer. But what I want to do now is show some functionality on how you can clean up these lines. Now on IDAS, the quick actions, there's this nice little map cleanup tool. It's actually a AutoCAD Map 3D tool that Devotech has decided to bring into Civil 3D. This can be used to clean up your drawings. So I'm going to say select all on a specific layer. So I'm going to select the layer on which my polylines are. It's going to automatically select those objects. And then I'm going to go look at my cleanup actions. So I want to delete my duplicates, erase short objects, and then specifically break crossing objects. I want, wherever we have polylines joining into each other, I want these lines to be broken up into individual objects. Let's say extend undershoots, and you can select a tolerance for these as well, and for the short objects. Also set up a tolerance for that. In cleanup methods, you can choose to modify the original objects, and you can choose to convert lines to polylines. It's very important for IDAS that you are using polylines. And then when I hit finish, and as you will see now, it breaks up all of these lines. So the long polylines stay like they are, but it breaks up these into different vertices here. All right, now I can run the Stormwater wizard. Let's call this Stormwater. Reference surface is final surface. I'll get to your questions after the webinar. All right, so the parts list that I'm going to be using is Stormwater. And then let's say we want to use a Rockler 1 meter manhole. And then, okay, I'm just going to stick with these defaults that I have here. Rockler interlocking class 75D, I'm going to stick with the 450 millimeters here. I want to process entities on this layer. Let's select that one. So you can also select it from the dropdown, or you can select the object in plan view. I do not want to use entity elevations because these polylines are drawn at a 0 elevation. All right, so I do not want to use the entity elevations. And I also do not want to erase the existing entities. And I simply hit OK. Select over the entire drawing. You can see that it filters out only the objects on that layer, and then hit enter. There you go. Let's quickly switch off that layer. There we have our entire pipe network drawn out for us. Now, do also note, please, that these pipes are drawn in the direction in which you drew your polylines. So it's very good to keep mind of how you draw your polylines, what your flow directions are going to be, right? Okay, so then that is basically it for the pipe network wizard. What you can then do is you can go and swap your parts. You can, for example, use the IDAS. Let me quickly show that to you here. You can, for example, use the IDAS swap structures command to swap multiple objects. Let's make this curb inlets, Swan. Let's say the catch put. So for over here, I'm going to make it right-hand side. Catch pit is 1.5 and the downstream catch pit transition length is 1 meter. Okay, then select my objects. I'm going to select this one and this one. Enter. There we go. You can also change it to something else. So let's say swap structures. I don't believe I had the right one there. Let's say the right-hand side, 2 meter downstream catch pit transition length. See, it just updates that. Let's do that again. Let's choose a 2 meter with a 1 meter DCT. So forth. I do know that on IDAS, objects, no part objects. So with these IDAS parts over here, you actually have this little measuring stick, which indicates to you where your end of curve should be. So you can then go and physically move these objects, rotate them and move them accordingly. So there's the end of curve, there we go. Although I did do this fairly roughly, you can use your snaps, you can use your reference points and so forth to go and move all of these objects accordingly. All right, so that is how the IDAS swap structures works. Let me just, for example, go to IDAS swap structures again. I want to make this an outfall. Outfall end network node. Select the outfall location here. All right. So that is how you can use the IDAS swap structures command. You can. That's the nice thing. When you have or when you use this swap part here for Civil 3D and it's on its own, it only does one part at a time. Whereas when you use the IDAS version, swap structures, you can select multiple objects and change those. All right. So that is the brief overview of the IDAS Stormwater wizard. It works exactly the same for sewer and exactly the same for water reticulation. It's just, I believe that water reticulation, no, it's exactly the same. Yeah, so that's how those work. Now let's quickly move over to the vertical design on stormwater. Vertical adjustments. Just want to give you some quick pointers there. All right, so I've just gone through and I've renamed some of these, or I just put labels on this pipe network just to indicate the names of these structures. Now, what I also did was I went and I created some alignments for my branches. So from the bottom here, from the first point here to the outfall is branch 1. I believe from this inlet here to where it connects into branch 1, that's branch 2. And then from here to there's branch 3, from there to there's branch 4, and then from there to there is branch 5. Yes, as you can see, I've already renamed them. So I have manhole 1.1, 1.2, all the way up until 1.10. These names will change even further when you swap the parts afterwards. All right, I do have an example where I've done all of those. Then for branch 2, I have manhole 2.1 up until 2.6 going into 1.7. Then 3.1 going up until 3.5 into 1.6. And then same for branch 4 and branch 5. Now, what if you want to adjust these vertically by use of IDAS? Okay, so as you can see, we currently do not have any, it's basically just following our NGL profile. Now, there's actually a nice function whereby you can regrade an entire network to suit specific criteria. That is going to be on the storm dropdown. Let's go to regrade network. Stormwater, okay. Minimum pipe cover, let's say 1 meter minimum and then 3 meters maximum. Max depth surface, I'm not going to touch that right now. Reference surface is final surface. You can match the location of the pipes. Now, these are all the same diameter right now, so it doesn't really matter how you match these to each other, but usually you would go with invert, I believe, stormwater. The start slope, so the slope of my first pipes are going to be 1.25% or 1 in 80. My minimum slope is going to be 0.5 or 1 in 200. And then my maximum slope is going to be 1 or 1.25% or 1 in 8. You can also specify a drop depth over your structure, that is from the drop depth from the first invert in your manhole to the second invert in your manhole. I'm just going to specify 0 there. Then hit OK. No outfalls exist in this network. Okay, so that's what I wanted to show you guys, is we firstly need to go and specify or change this part to an outfall. So let's go and say, swap structures, outfall. Okay, it's still on my default. Select that and rotate. So what I just want to quickly do as well is I just want to enter the pipe manager so that it just updates this entire network here. And then I'll come back and I'll do that again. It says no coordinate system has been found. So sometimes if you are working on an older drawing with a newer version of IDAS, you will have to just open up, some of your functionalities might not work. Okay, cool. So I'm not going to worry about that right now. Some of your functionalities might not work, so you would just need to come into your civils, into your pipe manager, and so doing, it updates your network just to the latest version, and then some of your newer processes will work with it. All right, so let's do that again. Regrade network, Stormwater. Happy with this. So it's invalid polyline, but there you go. The entire network has now been regraded. Do note that some of these pipes do go over the maximum, but you can just simply edit these manually. There's a quick way to do that in your pipe manager, actually. I'm not going to worry about those styles. I think this was the Stormwater 450. So that's just going to be a circular pipe. Circular, it just maps those objects. So let's go to plan view. Let's run profiles. Now, when you've got profile views, you can actually switch between these. So there's my branch 1, and it indicates where my branch 1 is. Branch 2 is my branch 2. So I'm just going to quickly go through these and show you some controls that you have over these. So on the profile views, you'll see that you have some grade pipes options here. You can specify a slope, you can specify a drop over structure, and then different grading options. So you can calculate the slope with a fixed drop, or you can have a fixed slope and calculate the drop over the structure, or you can have a fixed slope and drop, and it manually grades those. So to show you that, what if I want to grade? So I'm just going to select pipe 1 up to pipe 3 there. What if I want to just calculate the slope between these and just the fixed drop of 0? I can select those 3 in that order and say grade pipes. And it grades them. Some of these structures will adjust, but yeah, that's not that. We can just play around with these and it will basically fix it. So let me just go and look here. What happened there? Okay, now something happened over there. Just go close without saving. No. Oops. Just reload that into my pipe manager. Oh, I understand what I mean. So let's say I want to grade backwards from this point up to that first point. Basically what happened was I tried to adjust these inverts, but it didn't want to basically compute the rest of these. Okay, so it should have actually just taken this straight through. But let me grade backwards quickly. Let's say I want to grade backwards at 1 in 40, that is 2.5%. A fixed slope and drop. I'm just going to hit Alt 3 to update that. Okay, that's in the opposite direction. 40. Minus 40. Did that again. Not sure what is happening there exactly, but that's not too much of a problem. Just always. I think it might be because I'm working on an older drawing. Okay, so I'll show you that rather in the sewer drawing. Right, but you can adjust these pipes with some shortcuts. So let me show you the manual way, whereby you can use the Vista at the bottom. You can actually select one of these pipes and you can control the cover at the start. Something is definitely wrong with this. It's not showing my surface. Okay, but let me rather not worry too much about that then. I think I might have made a mistake in this drawing. I do have another one. Okay, so this is my analysis drawing. All right, so basically what I've done is I've gone and I've drawn out all of my parcels from my watersheds. And I've also, these blue lines are my longest flow paths for each of these catchments. My grid inlets, so basically what I've done is I've already rotated all of these grid curb inlets to sit correctly and to sit as close as possible to the curb lines and to sit within this little red part over there on the measuring stick. All right, so I've drawn out my flow paths by using my Civil 3D water drop analysis to determine those. And what I want to do now is I want to go and show you guys how you can analyze this. So how catchments work in tandem with your pipe networks. Okay. So the reason why we're using IDA so much is because Civil 3D does not provide this type of functionality on its own. All right, so IDA basically brings that into our Civil 3D environment. All right, as you can see, when you open this for the first time, your catchments will be gray. Now, your catchments will usually be on its own site. So I've created a stormwater catchment site on which I've placed only these catchments. So once I load that up, it's going to show me the numbering on my catchments. And basically what I need to go and do is I need to connect these curb inlets to my catchments. I also need to allocate a longest flow path line to each of these catchments before I can do this analysis. So I can go to my catchments tab over here that only activates once you have catchments in the drawing and you activate the site. So I do not want to exclude that. I'm not sure why that was selected. All right, so what if I want to go and add a flow path? Now you can go and add a flow or select a flow path polyline to go and add into this. So let me quickly go and do that. Which one is this? This is catchment 1. So let's go add a flow path. I'm going to select that polyline. Okay, it does pick up the flow path length. Not sure why it gave an error, but it did give me that flow path length. Okay, but I can also do auto flow paths. So I can select this entity to use as a filter. We just select all of these features before I do that. Auto flow paths. Select one of those polylines, and it brings them all in, and it indicates them to me over here with these orange dashed lines. Those are flow paths, and it also allocates an average slope over the surface. Calculates that automatically for you. As you can see, you can also change your hydrology method and your average slope method. Okay, now I want to add my inlets. So let's go auto inlets. Select auto inlets. And it finds all of these except for one. Okay, so you'll see that it draws it from the centroid of the catchment to the inlet. Okay, so you've got a little gray dash line to indicate which grid or which curb inlet is attached to which one. Now, as I can see here, catchment 5, that one doesn't want to be found. We've got a curb inlet 2.4 over there. So I can also go and manually add that 2.4, and it will draw in that line for us. All right, so our curb inlets and our flow paths have now been allocated to our catchments. Now what I can do is I can go and specify a runoff coefficient. So I've already specified a runoff coefficient. This was a combined runoff coefficient of 0.35. This is for pre-development flow. So we don't have any developments in here as of yet, only the roads and the overall NGL survey. So let's quickly go to Conduits. I just want to add a managed roughness coefficient here. Roughness coefficient 0.03, I believe. Okay, we don't have any design velocities as of yet. Now I can simply go both parameters. Let's make it 24 hours. You can right click anywhere and say analyze. It says failed. Adverse slope for conduit P 1.9. So it says to me that 1.9, pipe 1.9 has an adverse slope. So I can then go and look at my profiles. Watch 1. Slope. So it might be that the flow direction is in the opposite. Slope does look fine. 0.5%, which is the minimum. That's towards the outfall. So, not update results, but just update. Just going to add a direction label just to check. No, it's fine. Okay, interesting. So let me go back to my Hydrants pipe manager. Oops. Hydrants pipe manager. I do apologize about that. The stop share button was over my Hydrants tab. So let's just go to our profiles and we'll add a little bit more script to this over here. So let's say I want to unlock those two pipes, lock both ends, and I want to provide a slope of, let's say, let's fix slope and drop. Let's grade pipes. So as you can see, that is how you can grade your pipes. For some odd reason, in the previous drawing, it didn't have my surface. It didn't show me my surface. I'm not sure what went on there. All right, so you can grade your pipes like that. So let's see if we go back to our analysis here. There we go, that works. So I think the slope was just a little bit too flat. So let's go to our report. Reports, analysis report. And there you can now see your report for stormwater. All right, so you can go and have a look at your node depth summary, node inflow summary, node surcharge summary, flooding, and so forth. That's the input file. So guys, that is a brief overview of stormwater analysis. All right, so you can then also, the same as in the previous, in the bulk water example, you can update your results to Civil 3D, and you will then see your grade lines. See that these pipes should be there. I'm not going to go too in depth in these as well. But there is also a functionality for you to auto size your pipes further down. Right. That's the basics of analysis. Now, the last topic that I'm going to be going into now, I won't take too long with it, is going to be for sewer. Now, sewer works exactly the same as our stormwater, except for the fact that you have house connections in this one. So the way in which you draw it out, the way in which you model it with your polylines, and the way in which you analyze it is basically exactly the same for both of these. I'm going to say, okay, I'm not going to worry too much about that. Now, what I've done here is I've brought in my cadastral information and I've converted these all to parcels, and I just renamed them. So these are of a style residential 1. Okay, so they are of a residential style, so that I can go and apply the house connections to these, right? And I can also apply a inflow into our house connections on the parcels themselves. Now, house connections for sewer in IDAS is actually fairly simple. So let me open up my pipe manager. This network has already been graded and everything. All right, so I can just go and load up my site, residential parcels here. Now, once you load up your site, you will see that because this is a sewer network type, it loads up your house connections, and you can also have your house connection tab at the top here. Now, let me zoom in. Let's say, for example, we want to create a house connection for this parcel. So I simply select it in plan view. It puts it in the center of my screen there. And I can go and select, how do I want to model this house connection? Lowest surface elevation, nearest pipe lowest elevation, or nearest pipe downstream. Let's go with nearest pipe downstream, because I mean, all of these pipes slope downwards anyway. So how do we want the private sewers along the border or high to low point? Let's say high to low. Let's actually just say along the border. Let's go back to this one. 12, there we go. Now, you can either only add a house connection, or you can add a private sewer and house connection. You also have control to remove house connections and remove private sewers or move these. Now let's say add a house connection. You just choose your part type and click OK. And it will draw it in for you as well as provide a cross section, right? Showing you the invert elevation of your pipe. Now do note it does take into account a minimum cover at the start. So when you add in a private sewer, this will most definitely affect your cross section. So let's quickly do that. For the same one, add private sewer and house connection. It's going to add it in along the border. But now because we have a minimum cover and this ground is sloping downwards towards the northwest, it actually affects our overall section, and it now makes it so that our pipe sits above our house connection, which is not going to work. In other words, it says here at house connection type, pipe above house connection. So you would have to go and adjust your pipes like this. Now to show you how cool this actually is, if I select all of my parcels here, and I go and say add PS and HC, click OK, let me just quickly compute. And it's going to do all of our house connections all at once for us. And there we go. It does all of our house connections and all of our private sewers for us. Now, you can go and click on any of these parcels and view the cross section there. So you will automatically then know, even if you go to profiles, it's going to say SC1, SC29, so you can go and view where you need to adjust your pipes to fit for your house connections. All right, but I'm not going to go over that. That is basically just adjusting the vertical profile of your pipes. You can just go through it like that. So you can see that this entire pipe here basically has to drop to accommodate for these sewer connections. All right. Now, if I go to home, I'm not going to update results because I have not done analysis yet. I'm going to update this just so that it shows us our house connections. There we go. Do note this isn't all the template from Devatech that I use for this, so the styles aren't up to the latest ones in this current drawing. Now, just to show you guys the last little tip for this webinar, if you, for example, change, this is going to be fairly roughly done. If you want to go and change the private sewer, you can simply adjust that polyline. All right, so both this private sewer and the house connection here is polylines. You can adjust them. It is only the house connection itself that is a structure. So I've adjusted this private sewer. Now, what does it look like when I go back into Pipe Manager? It's just taking a little while to display all of these sewer house connections. Let's zoom in there. There you go. House connections number 12. It updates your private sewer as well as the section. All right, guys, and that is basically it. This was a very in-depth basically sort of like a demo, but I do hope that you guys picked up a bunch of tips from this and that you can see what is actually possible with IDAS when you use it in conjunction with Civil 3D. All right, so guys, that is basically it for this webinar. Let me just quickly open up the slideshow again. So Any questions? You guys are more than welcome to direct the questions in the chat box. I see that I already have some here. I have a long pipeline which I used IDAS to model. However, my long sections seem to be cluttered with information. Is there a way to do this? I'm not sure what information you are referring to that it is being cluttered with, because in the end, if you have long sections, it only populates with the data that you provide, with the commands that you provide. By having too many nodes close to, okay, sorry, I didn't read that last one. So it's just by having too many nodes close to each other. Yes, so you must be wary of that. When you do use IDAS, you have command over selecting which or what your minimum structure spacing can be from each other, right? So just keep that in mind. Just see the chat here. Kitani, yes, this is going to be uploaded to YouTube. I will show you guys the link to our YouTube channel. It just it's just going to take a little while. We just have to do a few tweaks, and then we'll upload it. We'll upload it onto our YouTube channel, and you can view it there at any time. All right. So guys, you have 3 questions. Okay, you're more than welcome to ask. I'll just give you guys a few minutes. You can type any questions you want, and then I will. And guys, just so long for you, there's the YouTube channel for any other videos that you want to go and check out. We have an entire library of videos with helpful tips and tricks and so forth.
Hi.
Hi.
Hi, Arno. It was me who asked those 3 questions that didn't make sense while I checked them out. I realized I'm working and I'm also listening. So that was
Okay.
a bit weird. So the first question relates to, I've seen, we've even called IDAS, the developers of IDAS before regarding, look, we've got this 64-kilometer pipeline with different pipe materials and lengths and structures in between. But then because we initially started with a polyline, we tried to follow the center line of the road as best as you can, and then you offset that of the center line of the road, of course. But we found that when we do our analysis and start generating our planned production, and then we notice that, oh man, our long sections just display a lot of data in between the nodes or junctions or structures. So are you saying that if we specify the minimum spacing between structures, that would sort things out, or maybe not?
Definitely. When you use the IDAS wizard, okay, also for example, either the stormwater, bulk water, whatever, the wizard, you have a setting at the bottom that specifies or that enables you to specify a minimum distance between structures. Now, this is very, very useful when it comes to the information that you provide on your pipelines, because you anyways don't want to have too many structures close to each other. But
yeah, because I can't see anything. I mean, that's it's really...
What you might also want to look at is the scale of your drawings, okay? Because all of your longitudinal sections and so forth is annotated text. So sometimes if you have it at, for example, scale 1 in 1000, it's going to be very, the text is going to be a lot bigger, okay? Whereas when you scale it down to, like, for example, a 1 in 500 drawing, your text is going to be a lot smaller in relation to your profile view. So then you must just maybe set up your drawings like that, do a few test runs, see if it's not maybe just the scale that you chose that affects it.
Look, we'll try that. Yeah, we just have this huge deadline that we need to meet, but our drawings just don't make a lot of on a design perspective it works, but I mean, if you try to give someone those planned productions drawing to maybe construct or install the pipeline, I mean, it's just it's okay. So if I'm getting you correctly, then what we must do is that we must try and redesign this pipe and then specify a minimum distance between structures.
Yeah, you can try it like that, because what happens then is because most of the time when you go and design this and you add in those points manually, okay, you don't really keep track in the mind of how close those structures are to each other. So it might be that the text is overlapping, and especially then when you've got a small pipe in between those structures, then you're not going to see any information for that, because it's going to be overlapping with a bunch of other text.
Yeah. The thing is, our pipeline has, because it's following the road, the alignment is following the road. I mean, we try to draw it as best to the center line. So we have all these nodes. Let's say we're going around a curve. So we have a lot of nodes going around the curve, and then on a straight line, obviously, and then and I mean that's just to draw a polyline. Let's take it on to IDAS. But then when we get to planned production, we realize, now the nodes are structures, and then I mean, some nodes we don't even want. They don't even have to be there, like and if you say we can do a minimum distance, it would be easier on us, because we would tell the program to say, look, man, every 20 meters or so, please take an invert level, pipe level, or whatever level, or whatever velocity that may be.
Yeah, because it's going to add in a structure at that interval. You can also just try and use the IDAS remove structures command to just remove structures and to pull a certain pipe through to the next one. So that just eliminates some of the redundancies in your model as well.
Sure, definitely. Okay, thanks. We'll try that out.
No worries. All right, guys. So are there any other questions? Let's just quickly see here. All right. So guys, if there's no more questions, I think we can end off this session. I just want to say thank you so much for making it to the webinar. I really appreciate your attendance. And I really hope that you guys were able to pick up some helpful tips from here, maybe help you make a decision in the future. All right. Cheers, guys.